Okay, everybody, we were graphing the other trig graphs like tangent, cotangent, secant, and cosecant. So the tangent graph looks like this, and here's why. If you look at the inner circle, the tangent is 0 at 0. At pi force, the tangent value is 1, which corresponds to kind of an amplitude, but the number here is 1. At pi halves, tangent is undefined, so we have an asymptote. Now, if you go backwards, at negative pi force, the tangent value is negative 1, so we have a value at negative 1. And at negative pi halves, tangent value is undefined. Now that's weird because the tangent value is actually thinner, not as wide, as all the other graphs. So the period of tangent is pi, not 2 pi. Now the amplitude really corresponds to whatever value is at the pi force, okay? Cotangent is similar, except for the values are different. So with cotangent, since it's 1 over tangent, tangent is 0 at 0, so 1 over 0 is undefined, right? 1 over 0. So 1 over 0 is undefined, or infinity, undefined, so we put an asymptote at 0. And at pi, tangent is 0, so 1 over 0 is also undefined. Now tangent at pi halves is undefined because it's 0 over 1, but at cotangent is 0 over 1, so cotangent at pi halves it's 0. Pi force, tangent's 1, 1 over 1 is 1, and at 3 pi force, tangent is negative 1, so 1 over negative 1 is negative 1. So the cotangent curve looks like this with its asymptote. Again, its period is also going to be pi. All right. Then, come on in, Nick. I'm recording the lesson. What you got?
Okay. I need you to sign the sheet.
Okay, so then, hold on real quick while I sign this for Nick. Well, you'll be on film, won't you, huh? What period? Third?
Yeah.
Yeah. This is a 6th grade camp or something? No, it's family. Okay. All right, where are you guys going?
We're going to Whistler.
Oh, have fun, okay. All right, have a good time. Yep. So, back to this. Cosecant is really 1 over sine. We know that by its identity. So I graphed the sine curve first. And since it's 1 over sine, where sine is 0, cosecant's 1 over 0. So I have an asymptote here. Sine is 0 at pi, asymptote there, and sine is 0 at 2 pi, okay? Now, for the cosecant, we know that sine is 1 here at pi halves, so 1 over 1 is still 1. And here at 3 pi halves, the sine function is negative 1, so negative 1 over is 1. Now, when sine gets small, it's the reciprocal, cosecant gets big. So these are the two paired graphs that make cosecant. Its period is 2 pi. Secant is just like cosecant, but it's 1 over cosine. So I really lightly drew in my cosecant curve. I'm sorry, my cosine curve. Again, where it's 0, we have asymptotes because 1 over 0 is undefined. Where we have zeros, we have asymptotes. We have zeros, we have asymptotes. Okay. We know that then at 1, cosine is 1 at 0. We know cosine is negative 1 at pi. And then again, if cosine is getting small, then secant is getting big, vice versa. And we get a loop like this and a loop like that. And that is the cosecant or the secant curve. Its period is also 2 pi. Then our homework, what we did is we did modifications of that. We made it 3 times as tall. We did an amplitude of 2 or a period of 2. We modified the tangent. We modified the secant, and we modified the cotangent. Okay, and that's all I have. If you have any questions, come see me.